In my last video, I showed this UI where we visualized how attention scores is being calculated, starting from creating the token IDs for each token, then query key value vector, doing a dot product between the query and key, and doing softmax, and then multiplying it the softmax with the value vector. So the same process we'll see in this video, how it's done in Python. So this is a Python code that I have, Jupyter notebook. So the first import that you can see is from transformer. We are importing some classes, AutoTokenizer, for creating the token IDs. Config will be used for getting some parameter for the particular model we are loading. And AutoModel, it's not being used in this code, but we have the import just to see a few things. So these auto classes that you see, starting with AutoTokenizer, AutoConfig, AutoModel. Similarly, there are multiple auto classes in transformers library. Those are kind of an interface to multiple different models. So there will be, for importing same model or initializing same model object for this particular model, bert-base-uncased, there will be a specific class that is a bert model. So we can have a bert model dot from pretend and this model name, and this auto model is kind of a wrapper around that or an interface around that one. So we don't have to provide that particular implementation class. Rather, we can directly use auto model from pretend and the name. Similarly, this AutoConfig and AutoTokenizer are there. So uh, doing this, I'm printing the value of each of these. So the tokenizer, you can see this is what it printed. It printed some details like for a special token, how it is generating a token for a special unknown tokens. So if this tokenizer has some 30k words, and this is the vocab size 30,522. So if some words that I'm passing to it to get a token ID and that does not exist in its vocabulary, it will return UNK for those. Similarly, for separator token, it is using this one, pad token, this one. These are some special character it uses from our input. So like there is an, for end also there is one special character is used, and yeah, this is the second print, the config one. So for this particular model, this config was created, and this config data is coming from a JSON that each model has in Hugging Face, and this transformer library is from Hugging Face. You can check this one. So if we Google, you can get this is from Hugging Face. There is another way to validate the same. To do a web show transformers. So this will show the author. The author is Hugging Face team, and I did not install it directly. I actually installed bert-viz, and that had this transformers dependency, and that way it worked, or that way it got installed for me. And yeah, coming back to this one. So for that particular model, the config contained these values. So for example, it is using hidden size of 768. This will be our vector dimension in our UI example. For simplicity, we had all these query key and value or two-dimensional vector. In this case, it will be using 768. That is coming from the config. And this is the bert model output. And we did the output of this one. This model object we are not using anywhere in this code. It was used in some other file, so that got imported into this one. Yeah, even this contains some values like original embedding, token type. This one in a later video I can show once I explore this model object. So next is this text we are creating, time flies like an arrow, and we are using the tokenizer that object that we imported in this step. So to the tokenizer we are passing the text and we are printing the input IDs. So just like in our UI example when we used to enter, so for example flies, it is generating a token ID of 721. It is doing the same thing here. So for each of the tokens, for time for example it is 101, flies it is this one, like it is this one, and it is this one, arrow it is this one. Actually you can see some extra. This is containing 1 2 3 4 5 words, and if you see this one, these are the 5 words and these are the special tokens 101 and 102, not part of our. So this represents a start and this represents end of the sentence or the batch. And this was the input IDs that we printed. This is actually the token IDs that we call in this UI example. And this is the entire inputs object. It contains some more info like the attention mask token type IDs. Next is uh, creating those query key and value vector. So before that, this UI had one thing missing that I mentioned in the last video also. So apart from query key and value, there is a token embedding vector also having the same dimension. In this case, it will be 2. In this case, it will be 768. Whatever came from the config of this particular model. So that is being computed here. So this for creating the token embedding, there is this nn.Embedding where we pass two values, the vocab size of the model and the hidden size. And instead of getting these manually, this was done using the config that we imported in the last step. So this config has those values, the hidden size as well as the vocab size. This is the vocab size. This is the same thing that we can see in this also, the tokenizer import. Okay, so using this, it created this inputs embedding, and you can see the output inputs embedding is the dimension is this one. We have 5 plus 2 special character tokens. So for that, it is a 7 vector we can say, each with 716 dimension. This is a partial print of that one, all those 7 vectors. And for simplicity here, we are keeping the query key and value same as the input embeddings. So whatever this vector is, the same vector value we are assigning to query key and value as well. And dim k, that is the dimension of the vector, we are getting using key.size -1. That is key had the size this one, and -1 will give us the 768. So printing that gives us 768. Next is whatever next steps we did, that was doing the dot product between query and key using the torch.bmm and dividing by square root of dimension k, 768. This would have been implemented in this UI example, and this was for simplicity just the dot product, not division is not there. And going below, the final step, doing a softmax to get the weights, and here, so doing the softmax to get the weights, and then using torch.bmm again, weight and values are multiplied. Values again, the vector that we initialized same value as the inputs embedding. And this is the final attention output. In this dot product, you can see that here also the sum is 1. You can see the first value is close to 1 and rest are 0 point and 11 zeros like that. So it is very small number. So overall the sum will be rounded to 1. Similarly for this, you can see this moving. First vector has first one as value 1, second one as value 1. Similarly the others. So yeah, that's it for this video. I will share this code in the comment or the description of this video.